Question number 6. Find the nth term of each sequence. So the first sequence is 8, 15, 34, 71 and 132. If there is a difference which is common between the terms, then we can use the formula for the common difference sequence, which is a plus n minus 1 into d. But clearly we can see that here the terms don't have a common difference. So this is not a linear sequence, which means this is not related to the formula a plus n minus 1 into d. So we will see whether this is a quadratic sequence. In order to figure out whether the sequence is a quadratic sequence, we need to find the difference between the terms. So let's find the first difference. The first difference, 15 minus 8 is 7, 34 minus 15 is 19, 71 minus 34 is 37, 132 minus 71 is 61. Clearly this is not a common difference. We will again remove the difference to see if the second difference is common. So 19 minus 7 is 12, 37 minus 19 is 18, 61 minus 37 is 24. The second difference is also not common, which means this is not a quadratic sequence. Let us try finding the third difference. 18 minus 12 is 6 and 24 minus 18 is 6. So we see that in this case the third difference is common. When the third difference is common, this is known as a cubic sequence. So this is a cubic sequence. Now, cubic sequence has n cube embedded in itself. Now, n stands for 1 for the first term, n is 2 for the second term, n is 3 for the third term, 4 for the fourth term, and so on and so forth. So, if I write n cube for the first term, n will be replaced by 1. So we have 1 cube, which is 1. Now what change should I do to this in order to get 8? I can try adding 7. So I will add 7. So I get 8, which works. But I need to check further for at least 2 more terms. So for the second term, n is 2. So we will plug in 2 in place of cube. So 2 cube. That gives me 8. Now if I add the same number 7, I get 15, which is fine. I can try this further with the third term. The n value for the third term is 3. If I want to try finding out if this formula n cube plus 7 is also good for the third term, I will write 3 cube plus 7, which is 3 3s are 9, 9 3s are 27, plus 7, that is equal to 34. So clearly this formula works for the given sequence, and the formula is n cube plus 7.